Hi, I'm Jon Williamson, and I've also been working as a part of the EBM Plus network of researchers interested in evidence of mechanisms. IARC, the International Agency for Research on Cancer, is one of the few organisations that takes evidence of mechanisms seriously, and we've been attending some of their evaluations of carcinogenicity to see just how they do that. One of the more interesting recent evaluations has been the evaluation of styrene and styrene oxide. This has been interesting because it was put forward by the members of the mechanisms working group at that evaluation that styrene can only cause cancer by being metabolized to styrene oxide. So there's a pathway from styrene to styrene oxide and then on to cancer. This is interesting as a mechanistic hypothesis because it's a different kind of mechanistic hypothesis to the ones that IARC usually considers. Normally, IARC considers 10 features of carcinogenicity, or 10 hypotheses as to how the mechanism for carcinogenicity might work. In addition, IARC considers a mechanistic class hypothesis. This hypothesis only applies if a particular agent that is being evaluated is deemed to be part of a class of agents which have all been established to cause cancer in exactly the same way. So currently there are 11 mechanism hypotheses that IARC consider. The 10 key characteristics of carcinogenicity and the mechanistic class hypothesis. The styrene oxide hypothesis, that styrene only causes cancer via styrene oxide, is interesting because that's a completely new kind of mechanism hypothesis that needs to be taken into account by these sorts of evaluations. You can't deem styrene to be a very likely cause of cancer, but deem styrene oxide to be very unlikely as a cause of cancer, because styrene can only cause cancer via being metabolized to styrene oxide. This shows that the landscape of mechanism hypotheses is shifting all the time, and we constantly have to take new considerations into account to do proper evaluations of carcinogenicity.